Hi everyone, I am Ashwini. Today I am excited to walk you through my Wake-A-Mole game project developed using System Verilog. I will go over the design logic, explain the test bench and show how we stimulate it to get a visual output of how it all works. Let's dive in. First of all, what is Wake-A-Mole? It is a fun game where moles pop up randomly and the player tries to hit them as quickly as possible before they disappear. Each time the player hits a mole, they earn points. The moles keep popping up faster, making the game more challenging as it goes on. Coming to the project overview, to start, the Wake-A-Mole game works with a few simple rules. The first one is moles pop up randomly in 4 positions. Second one, the player has a chance to wake a mole while it's active. Third one, for each successful wake, the score for the mole increases. We will implement this logic in System Verilog, simulating the moles appearing and being waked. Now let's take a look at the main design code for the project. I have defined a module called Wake a Mole where we set up the game logic. The first one is input and output. We have a clock for clock input and reset underscore n for reset. Mole underscore wake is a 4-bit input, each bit representing a wake attempt for each mole. Next, mole underscore active is the output that shows which moles are currently active. Then score is a 4-bit output that tracks successfully wakes for each mole. The second one is random mole activation. Inside the always underscore ff block, we initialize a timer. When the timer runs down, a new mole or multiple moles randomly appear by setting mole underscore active using $random. The timer result each time, so new moles appear at set intervals. The third one is wake detection and scoring. Another always underscore ff block checks each mole status and detects if a wake aligns with an active mole. If they do align, the score increments and the mole reset to inactive, waiting for the next random activation. The design logic is simple but effective for tracking each mole state and player score. Now let's look at the test bench, which is essential for simulating the game. The first one is setup and initialization. We start by defining our variables like clock, reset underscore n and mole underscore wake. The simple dump file and $dump bars commands are used to create a VCD file which will let us visualize the simulation. The second one is clock and reset. The clock signal is toggled every 5 times unit. Next we activate the reset initially to clear all states, then deactivate it to begin the game simulation. The third one is simulation sequence. In this sequence, we stimulate a player waking different moles. We set mole underscore wake to different values to mimic attempts to hit various moles over time. After trying all positions, the test ends with $finish. This sequence helps us to test whether our design responds correctly to each wake attempt. Now running the simulation and viewing the VCD. To see how the game works, we will run the simulation and generate a VCD file. The VCD file allows us to visualize the changes in the mole underscore active signals, the mole underscore wake attempts and the score updates. When we open the VCD file in a waveform viewer, we can see random mole activations based on the timer. Next, the score incrementing correctly when the mole underscore wake aligns with an active mole. The VCD file gives a clear view of the game mechanisms in action. Now coming to the conclusion, in summary, this Wake-A-Mole project demonstrates how to design a simple game using System Verilog, complete with random events, user interactions and scoring. It's a great example of combining basic digital logic concepts with a fun game mechanism. Thanks for watching.